as a recognized national research institute. Today, we are privileged to have with us one of the country's most distinguished entrepreneur, thought leader, and inspiring personality, Dr. Anand Deshpande, who also served as the co-chair of the BRIC governing body. We look forward to his insights and inspiration on this special occasion. Before I introduce our distinguished speaker, I would kindly invite our Honorable Director, Madam Dr. Jeetaru Sharma, to share her invaluable thoughts on this very occasion. Presentation will come here.
Thank you very much, Dr. Sonu Gandhi. And can I just, before I start, can I just get a pointer? A very good afternoon, greetings of our Institute Day to one and all. Yeah, thank you. Dear colleagues, student fellows, all our employees, admin staff, and all the Niabians, and above all, the speaker for the day, Dr. Anand Deshpande. Dr. Sonu Gandhi was telling a little bit about you, and I think we would all know him in a while. First of all, I, on my own behalf and on behalf of all the NIB fraternity, welcome you at this occasion, Dr. Deshpande, and thank you for being amongst us. I was trying on several other occasions, but he keeps very busy, very occupied, and I've personally heard him very effective, lot of ideas. I'm sure that we all will be happy to interact with him post and during his lecture. With that, it's a time to kind of have a look what exactly we really have been doing from last August till this 11th of August 2025. So as I already said, it's happy to be here and good wishes to our Institute Day. And she has rightly mentioned that when did we begin? So the Institute is just 14 years old. And this is what is our vision and mission. And these are our some of the areas where we work in, which I shall really touch upon when I come to the technical part of it. The journey began as we were talking, Dr. Anand, that it was late Professor M.K. Bhan. This institute is his brainchild and got started in May of 2011. And these are some of the early years. And the permanent campus, what my colleague said, today is a day on 2018 when we moved in, and that's our Institute Day. Since this is what little we could think of in the memory of evergreen Dr. M.K. Bhan, who is known for his rotavirus vaccine. So the Institute honors a lecture for all his contribution in the not only the pediatric biology, but in the related areas. So just some of the glimpses. It's good to kind of visit and revisit once again what all we have been. And also it's a day to mark few people, and there are many people who have played a significant role. I would like to make a special mention of Dr. Arun K. Rawat, who was the director and scientific nodal officer of this institute. He has really given a lot of inputs and hard work, and continuously he supports all NIB activities. And for sure, the founder director, Professor Redanna, who's still with us on very many occasions, and NIB is in his heart always and supports. These are a few glimpses like how did we grow. The previous director, Dr. Majumdar, has put all of his efforts to bring all the civil structures at place, though foundation was laid by the first director. And today we are here at our campus, lush green campus in 100 acres of land, right at the prime area of Gachibowli. So if we just see the journey of what all we accomplished or achieved with the fantastic group of colleagues. So these are the areas we were autonomous institute. We are still autonomous, but slightly in a more decorated manner. There is an adjective added, the brick. It was on November of 10th, 2023, and we have become one of the iBrick institutions. As I said, that these are our areas, but these areas are being addressed by this 25 fantastic colleagues, scientists specifically. And all these 25 scientists addresses one or the other areas over here. This is the PhD scholars who are enrolled, and this 91 number does not cover the recently joined students through I3C Brick PhD. So we have right now a bunch of them with us, and this is just a table saying that how we have been doing. So earlier when we were growing, some of the students were coming here through Manipal also, but right now we are all with RCB. And we do a lot of student activities, but just to say a mini PhD symposia. So we have already one hostel for students and fellows of 100 rooms, and it was just not more than 85 hours ago when Honorable Minister, Union Minister Dr. Jiten Singh has inaugurated, and we have laid down the foundation stone for new hostel block and type 4 quarters. It is also very important for me and all the Niabians to thank the current secretary who has been ever supportive and encouraging all the things. Besides scientists, because to roll on, all the wheels are important. So our admin wing is small but very effective. And so our technical officers and the in charge. So together we do it. And this is our CIF, just to give a glimpse, especially to Dr. Anand. And important is not that how costly our equipment, more important is how effective it is, how effectively it is used, and how do we manage it. So since we have animal houses, both large as well as small animal houses, so animal house in charge is Dr. Jayant Patil, Dr. Jayant Hole and Dr. Himanshu Patil. They maintain with their good group of people, and they are our experimental animals over here. The institute has a facility to use BSL-3 lab and ABSL-2 laboratory. This is the inside view of our other facilities, like facilities which are housed within. We do have a vaccine testing laboratory. It is now approved and funds given for human vaccine testing. So other than Kasauli, now NIAB would also be one place where all the human vaccine testing would be done. It's official because we have had it for COVID, but we wanted to get it used for veterinary vaccine testing. However, PMO approved and governing body approved. Thank you very much, Dr. Anand and all other people in GB. So how is our research being, translated and get as an output of publication, patent or whatever? It's a number just to say. The number doesn't matter. What exactly matter is, I'll come in the slides. So we are not after the number, we are after the what exactly it conveys. But the good part is, number wise also we are not that behind. Our colleagues have been really doing very well year after another, and shall continue far better. So not only publications, it has led to five technology development, and 5 technologies have been transferred to the stakeholders, and 3 are in pipeline. Some of them are patent protected, some of them have patent on in the pipeline eventually to see. It was a very good day for all of us, and especially all those inventors when 9th of August, they all 5 technologies were released and very well absorbed by the science cohort across the country and the stakeholders in at large. Some of the patents number is appreciable, and some of the patents have been granted. Precisely 3 patents granted last year, February, and end of the year 2024. And the patent granted toxoplasma and the brucellosis, actually it is not for the kit which was release, but this is a patent granted for entirely a different purpose. There's a novel anti-inflammatory peptide. So the pathogen secretes something. I'll limit my discussion over here, but like to say all the 5 technologies which were released by Honorable Minister were DBT supported. So the first was Brudiva. It's a zoonotic disease, and one can differentiate between the infected and vaccinated animal. And the laboratory of Dr. Girish Radhakrishnan is continuing with this work, and they are moving ahead. And now they are planning to go for large animal challenge trials, so that they would really plan and target for a vaccine. Likewise, the another technology which got released, it is a patent protected one. That's on a parasite, which is again of a zoonotic importance. And his laboratory has been continuing with some details why exactly it is so important. And the laboratory of Dr. Abhijit Deshmukh has published 2 very important papers, one in May, one in June, in Nature Communication. And his approach is one where he's targeting a drug molecule, another as a vaccine approach. So now coming to what all Institute has been doing, our bioinformatics genomics team has been doing very well, and they have developed an indigenous chip, a genomic chip for identifying the cattle breeds. This was inaugurated by Honorable Minister of Science and Technology in 2021, and a lot more has happened after that. We went with the other stakeholders, sign MOUs, and all together what has happened, keeping this chip as a base data and little bit from other people. Actually, this GAU chip, they named it the joint one as a GAU chip, and Honorable Prime Minister released it last year in October and has dedicated it to the nation. If I talk about the One Health Consortia, which is another very important activity countrywide. Why so? Because we know approximately 68 to 72% of pathogens are zoonotic in nature. So 4 years back, DBT started a first consortia, One Health Consortia, and across the country, people are there. They are from veterinary side, medical and wildlife, and all the 7 sisters from Northeast, with an aim exactly to do the surveillance and and present the data, maintain the data, robust data for this, as I said about the zoonotic diseases. So this is what exactly is going on right now. We are having sample size touching almost more than 45,000 to 50,000 at place, and alongside this institute was running a flagship program again with 2 other important zoonotic pathogens, a bacteria and a virus, and a detection, JEV detection technology was developed. This was also the technology was released as an outcome of JEV flagship program. Besides, we have some of the other electrochemical based, sensor based techniques which are at place. A while ago, I was introducing you to our colleague who works on Mycobacterium tuberculosis. So the institute has a first complete genome for Mycobacterium oryzus, and they make the organoids, and they try to work not only the pathogen linked science but also the drug related things. It was the year 23-24 when the country has seen a cattle pandemic, LSDV. So this institute has given its humble yet important contributions in two ways. One, that they design a multi-epitope protein, which could probably be work as a subunit vaccine. And also one another colleague, she along with other team people has given a complete genome sequences. It's there. And now the happy thing is actually our consortia, our not only the consortia partners and the scientists, but now these two people will be going ahead with the in a partnership with the funding from Bill Melinda Gates, and will start in a week's time for this. It's not only LSDV, some other poultry viruses. On the reproductive biotechnology side, so there is a goat model developed for PCOS, which is a serious health concern in case of human beings. And what exactly is being done? The whole idea and objective is how to rescue or rather enhance the longevity of an egg, the female germplasm. So they have some molecules which are supposed to be patent protected, and they are moving ahead with that. And they have a mice data, and now they have a goat data as well. And then one very important laboratory here in this institute is of a transgenic animals. So this is aligned with our BioE3 policy for biomanufacturing. Animals are the best model for biomanufacturing. So we have follicle stimulating hormone, which is used for IVF and linked things, superovulation and other things. It comes in the milk of a rabbit, and this is what we could succeed. And now they are going ahead to make this biotherapeutics at a larger scale, not the same hormone, but some other molecules in the goat through the goat milk. There is an organoid system at place. So this lab is not even 3 years old, but they could really have some significant leads where they made up placental organoids, and they're now working with the Brucella group if it can succeed. The laboratory also works on stem cells and stem cell based therapeutic approach. There are two major people who are focusing on adult cells of different origin, adipose derived as well as mesenchymal ones. So we use it post scaffolding to many things. And through National Biopharma Mission, we received the sanction order 3 days back. We'll be developing very many things with high media. And nation's first animal stem cell biobank could be inaugurated on Saturday. The group which is working on nutrition, and so idea is to generate the alternative feed and feed resources. And they are doing so many things, not only using the nanoparticles, and also they are collecting the Raman fluid. They are working with other I3C BRIC plus institution to generate the cattle feed with the waste from the plant institute, and with the help of one institute, so anti-nutrition factors could be taken away. So this is a precise strategic roadmap of R&D on large animal with which we focus and we move ahead. And it includes all the important part, including the biomanufacturing. We call it bio-menu farming, which really puts all our niche colleagues into this areas. NIB strongly believes, and its vision and mission is in alignment and syncs very well with the BioE3 policy of DBT, duly stamped and approved by central government. And we do one important thing, that is meeting livestock farmers with our scientists. We do it as a regular activity. The same thing was done on Saturday. One of our colleague has arranged a lot of farmers who were aware what do we do, and they were interacting with honorable minister also with their viewpoint. And this is some of the gallery, what all we do. We do all important things what is at place, and we do it very well, be it science or be it other linked things. So just to give a glimpse of like what all we do, and this is a picture of, if you can recall, Dr. Deshpande, the placement thing we were talking during GB. So this was arranged over here, and the placement went very well. So 3 people which we were knowing that time, but now the number has increased. So 5 of our students are placed to one or the other, company. They're all private people who have taken them. So some glimpses of workshop, conferences, and some important student-led activities. And then I'm very pleased to share that third time we really have got a Swachhata Pakhwada award from DBT. And these are some of the glimpses of Saturday, which we all really cherished. The happy day for us. With that, thank you very much for patience listening. I'll just take a minute, and we have a colleague, Dr. Shailesh. He was very keen on, when you come, I should really put it that their lab is generating some data on AI ML, animal-based work, which you can take it up during the discussion time. And I stop here. Thanks.
So, okay, sir. Okay, sir. Sure. So it is my privilege to formally welcome now Dr. Anand Deshpande, who is the founder, chairman, and managing director of Persistent Systems and co-chair of governing body of BRIC. Under his vision, Persistent has grown into a globally recognized, publicly traded technology company. In 2023, Dr. Deshpande received the EY Entrepreneur of the Year award for his innovation-driven leadership. Before founding Persistent, he worked at Hewlett Packard Lab at Palo Alto. A noted technologist and community leader, he has held key roles in NASCOM, ACM, India, CSI, SEEP, and CII. And currently, Dr. Deshpande is focused on data education and entrepreneurship. He serves as a part-time member of UIDAI, trustee of the VLDB Foundation, and involved in Healthcare Data Initiative. He is the chairman of IIT Patna, interim chairman of IIIT Hyderabad, and adjunct professor at IIT Bombay. With this, I would like to invite Dr. Deshpande to come on the stage and enlighten us with his views.
Like this? Okay, can you hear me? So first, it's an honor and a pleasure to be here. Can I request all of you sitting in that corner to please come in the center? No, we are just after lunch, so thoda rest. Little movement would be good. So I'm going to talk about AI today. Right? Come in front, meaning we can, that way, we can see each other well. So, I asked ChatGPT what should be a good title for today's talk that might bring more people to attend. So it gave me 15 options. So I sent those to ma'am and she picked this one. But no, leave the lights on. But when you go to school, you have an essay that you prepare in advance. So like somebody says, you have one essay on the cow and they ask you about the dog. Then you say the dog has cow as a friend. And you say the same thing again. So the title is what it is, but the slides are the same as what I have had before. Okay, so I only created the title. And with the title, you can always ask ChatGPT to give me a nice picture. So of course, that's where that comes from. All right. So first, thank you very much for inviting me to NIAB. It's my pleasure to be here. I visited many BRIC labs now, but it's good. This is my first time to NIAB, so I'm quite excited to be here. And it's always exciting to visit biolabs because I know nothing about biology. So it's always a good place to learn for me. And I get very excited talking to students, especially because I think, they are the future of our country, and the enthusiasm and the energy that you get in chatting with students is always very exciting. So I'm really looking forward to learning from you today. And that's why I'm here. So first, let me congratulate you. I thought it was 2010, but I guess it was my mistake. It should have been 2011.
We are running into a 15th year.
Well, yeah, but again, congratulations to you for your 14 years of completion. So very briefly, as I mentioned, I have no biology training at all. I am trained as a computer science person. I did a PhD and all that. And for the last 34 years, I've been part of Persistent Systems, where I run the business. But last 5 years, I've almost 6 years now, I've been chairman. So I have a full-time CEO who runs the job. So that's why I have time for doing all these other things. And in terms of what I do right now, I'm working on three broad areas. One set is around entrepreneurship. So we have a foundation called Deyasra Foundation. And then I run another program called Second Orbit to help companies scale. Then I've been working with Rajesh and the Department of Biotechnology, specifically around BRIC. I'm quite active in the CS community around VLDB and ACM, and then some other things here. So these are various things I'm working on. In terms of my interaction with anyway, this is just a disclaimer that I'm not really talking about persistent systems here. I'm just giving you a little bit of an AI overview. I want to start with a first story of my only farm interaction I've had, okay? So this was I did my PhD from Indiana University in Bloomington, which is really the Midwest, as they call it. So I had a friend, his name is Tony McAfee. This is a more recent picture. This is not from 1987. He lived in a small town called Amboy, Illinois. Today its population is about 2,500 people. So it was much smaller at that point. And his family was a hog farmer. So they had lots of pigs. And he was kind of a grad student with me. And we said, oh, we should go see your place, spring break, all this stuff. So we drove to his sort of small town, Amboy, Illinois, which is close to, this is Chicago. So it's about, a little bit west of Chicago. And they had lots of pigs in there. They had a big yard with lots of pigs. So the first day we went, we saw this litter of, not this one. I didn't have photos and cameras at that point. So this is more recent. These are small piglets that they found. And the first day his dad said, oh, we have new pigs, new breed. And then they castrated all of them in front of us. It was like, man, this is not what I understand well. And the next 3 days we cleaned the pig sties with him, because that's what everybody there they had 4 boys at home, and everyone cleaned the pig sty for the weekend. And we had lots of pork. That's what it was. After that, I was so glad that my father is not a farmer. It's a lot of hard work. Okay. So, yeah, so that's my only interaction of having stayed in a real farm. The other thing, when I talk about AI, currently I'm on the board of BIF. Okay. And you may be familiar with BIF. And when I first showed up at BIF, they said they do a lot of AI. Okay. And I had no clue what that meant. Okay. So then they told me that, oh, by the way, AI, we are a leader in AI, and we do artificial insemination. Okay. And for me, AI is something very different. Okay. So today I'm not going to talk about this AI. This is stuff you know well. I'm going to talk about artificial intelligence. Okay. So now a little bit of this slide. Okay. So on 15th of July, I got invited to speak at IIT Kharagpur. So I'm an alumni from there, and they had the convocation. So they invited me there. So they said, what will you talk about? Now, computer science people are very scared of AI right now, because AI can do everything. So then the question is, if AI does everything, what will humans do? So that was a topic I was asked to speak about. So I posted this on LinkedIn, and I got lots of responses. So here's what I did. So I think I'll show you the link somewhere else. But anyway, so I got a whole sort of reactions on this, and I'll share some of that with you. But before I go any further, I want to understand how much AI do you guys use, meaning artificial intelligence, not the insemination one. How many of you have been using ChatGPT or something like that? Some. Everyone must be using, right? What all have you used? ChatGPT, Gemini, Claude, Napkin, huh? DeepSeek, Claude. What do you use it for? Scripting. Nice. And have you been trying out all the vibe coding and all of that stuff as well? Okay. So anyway, um, so here's where I wanted to start. That AI currently is going to. We all believe that AI is going to be as disruptive as the internet or the mobile phone. All of you, I'm sure, have the 90s. We saw the internet coming in and completely disrupting how we looked at things. Everyone started to use internet in a big way. And in the 2005-7 onward, the iPhone and then, of course, Geo transformed how we get access to things because of the mobile phone. It is expected that AI will have the same level of consequences. I call this, you got ubiquitous computing here, connectivity, then compute and apps, and then intelligence. So intelligence on tap. This is really what is very exciting. So that's what we're going to talk about today. And what I'd like to see happen today is that I'd like this to be a very interactive session, okay? So feel free to interrupt me and disagree with me, because that way we can see what is going on. And I'm sure there are many questions that you have about AI. I have actually two sets of presentations here. Depending on what we want to do, we could switch to one or the other. One is a more technical on what is the computer science behind the AI. And the other one is regarding the consequences of AI to society and other things. Which one do you think we should do more of? You want to go technical? Huh? Let's do raise of hands. How many of you would like to do a technical one versus how many would you? Let's ask technical ones. How many of you want? And those which are the consequences of AI. Actually, more people want that. Okay, let's see what we can do. We'll mix and match both. How much time do we have? So we do both also as an option. Okay, let's see. So when I started to do this particular presentation, I first made this in January, and I created these sort of, I thought were bold ideas. But over a period of time, they became not so bold, meaning it's this become true now. So I sort of, instead of redefining what the next bold things may be, I just said not so bold ideas. So here are the 6 ideas that I think I want you to understand. One is that we are at the beginning of the AI journey. So we are nowhere near done. There's a lot of AI that still needs to be done. And if people are trying to figure out if they should be studying AI or anything like that, I can say this with some confidence that there is a lot of AI still to be done. The second is, of course, AI will shape humanity's destiny. There's so much that AI can do. So AI is not going to just affect the computer science people, but it is going to affect all kinds of people. Everybody will be affected by AI in some form or the other. Third, this is sort of where we get involved, in the sense, computer science people. AI will write better code than humans. So now the problem is, what should software engineers do? So one of the challenges that we have been thinking a lot about is, what should software engineers do if AI does all the coding? And then I don't know how many of you are familiar with agentic AI, but that's been the hot topic for the last 6 months. Everybody's been talking agents. And agentic AI can do many exciting things because they can actually get things done. You can connect different processes, and you can really redefine industries using agentic AI. And they will have unprecedented power and risk. And then finally, AI is enhancing digital divide, and we should talk a bit about how India must invest in AI. And of course, unchecked AI is a huge risk, right? So anything you disagree with, you want to comment on this? Let me do this. It's getting warm here. Let me remove my jacket. Okay. Yeah, let me just skip through this. Since if we have to do both of them, then let me not spend too much time on this. I already shared the high level summary. Let me just skip through this. Okay. So I'm switching to the other presentation now. Sorry, I need to share that. Okay, so this one is a little bit more technical, but it will explain to you what is AI, what AI does, and how AI works, and that will give you some idea on, how it behaves in a certain way and how we can deal with it. You okay? So please stop me if you see something that you would like me to elaborate and explain, because that might be more useful. So all of you would be aware that right now the AI that has sort of gotten exciting or is the rage is the generative AI, as they call it. It's being referred to as Gen AI, right? But AI has been around for a long time. It's been around for more than 60 years or so. Previously, we all used predictive AI. Predictive AI, what we were doing is that we would look at existing data sets, right? And then find out patterns within their existing data sets. And on the basis of those patterns, predict what might be done. It was predictive in that sense. Now, what has happened in the new context of generative AI, when we are using very different kinds of architectures to do this, we are not anymore predicting what is there from existing data, but looking at generating new facts on the basis of existing data. So we are not just asking yes, no questions or give me the value for filling in the blanks or something like that, but we can do a lot more with Gen AI right now. So that's really what we are going to talk a lot about. Now, one of the main architects of Gen AI today is Geoffrey Hinton. And those of you who have not seen some of his work, you should go online and look him up. He got the Nobel Prize for Physics this year, and he actually writes a lot about all kinds of things. But he has a very negative view of AI. He thinks AI is going to basically overpower the world and kill everyone eventually. So he has a very negative view on this one. But it's worth listening to him. So as you would notice, right? So he started working in he has a bachelor's of arts in experimental psychology from the UK, did his PhD in artificial intelligence in 78. And in 86, he wrote this very seminal paper around backpropagation. But that was in 86. For 20 years, nothing much happened in this. This is a very interesting example for researchers to think about it. He had a conviction that this particular neural networks with backpropagation could solve AI-like problems. But the compute environment, the infrastructure and all that was not ready. So for nearly 20 years, it's called the AI winter. Nothing much happened. But he kept on it. Many people were working in this area in the 80s. All of a sudden, they gave up that they don't believe that this will generate real results. So they sort of moved off this area into other areas. And then this guy just kept at it. And in 2006, he sort of came back and You got AlexNet. Some of his students here, which you will see names of, are all running different companies right now. Yeah, Jan LeCun is right now the CTO for Meta, which would be Facebook and other things. Ilya was one of the key guys at OpenAI, and now I think he has his own company. But a lot of his people are been working in this area. So, as researchers, I find this work very exciting because, a lot of times we work on a problem and then while we might believe it, you don't see the results and you just kind of move on and are not persistent enough to go after it. So this is really the difference between what you could say is very specific to Jeffrey Hinton's work. Why is AI so hot right now, all of a sudden, right? It's been around for a long time. But in the last 4 years, all of a sudden, because of OpenAI and ChatGPT, all of a sudden, everyone has sort of caught on to AI right now. Clearly, this has happened because of advances in deep learning and neural architectures, scalable hardware parallelism, availability of tools to process large quantities of data, improved algorithms, right? And then availability of tag data for techniques for pre-training, fine training, post-processing, and efficient deployment of tools. I want to keep this point that you should think about a little bit more about availability of data. And I think as a biological institution that you're working on, creating these data sets that can be used for various kinds of things is, I think, a very tricky but an important problem. And I think we haven't done enough well on that one. So this is something that you might want to think about as you look at interesting problems to work on. So foundational models are large language models, or LLMs as they call it. These are typically, when people talk about foundational models, they are talking about LLMs as large language models. They are trained on massive data sets. They are powered by the transformer architecture, and we can talk a little bit about this as we go along. They perform tasks like writing code, summarizing documents, writing new articles. They are deployed across domains from education to computers, whatever else. And some of the ones that you are most familiar with, these are the general purpose LLMs. These are the large language models, which are sort of the fundamental ones that you can get. And this is a short list of these as I updated it recently. And every few weeks, there have been new ones that are coming up. Like last week, there was a big launch of GPT-5. Gemini also launched a new model, which I think is very exciting for scientists, especially. You might want to look at it. And then Claude had some small release that came out. So every week, there has been a lot of, the new one from Google have been actually quite interesting. You may want to take a look at the Gemini 2.5 and also the stuff around Gemini 2.5 Flash. Quite interesting for science point of view. So do you know what a model is? So essentially, to think about a model, think about, so one good example that I'm going to share with you is a model of, so what a doctor would do. So if you go to a doctor, normally doctors are trained on certain cases. So they see a case, somebody is sick, he has fever, this, that, and they can prescribe medicines. So like this, they kind of build a model in their own head about what should you do when certain conditions happen. So certain symptoms, certain readings, and they can predict what might be wrong and then predict medicines for it. So this is what they do. Now, if they see some case that they have not seen before, in a predictive model, what would happen is you would have had to see that case before to say if I can prescribe some medicine. But doctors usually know that, okay, if it has mostly these symptoms, something else, they are in a pretty good position to give you an answer, even if they have not seen the case before. Right? How are they able to do that? They are able to do that because of a model that they create. Now, models are something that we have created for many years. One of the earliest examples of this will be Galileo's experiments. So what Galileo did was he dropped balls from the Leaning Tower of Pisa, and he counted the time it takes to come down. And using that, he created a plot like this one here. So he has height and time. So he took different heights and see how long it takes. And he kind of he saw these plots. And then you do some curve fitting and find an equation for setting this up. Now, having created an equation like this, I can use any height that I want, even if I don't have an observation for that in the past. Because my model is so deterministic and I have an equation, I can always find out what the real value is, right? So like this, you have lots of training data. You build a model, and once the model is trained, then you can look at any image and say, okay, fine, this is what it is, right? So now this has become a very useful thing to do. And with all the new models that are available, especially the open source ones and all of that, you can create your own model that trains for your own thing. So one of the things that I would encourage you to consider is, okay, you all work in a whole bunch of large animal kinds of things. Would it make sense for you to build your own model based on data that you have for your own study? Are you with me? So the way these models are set up inside of the current computers, the deep learning models that they use something called neural network. Okay, so what a neural network does is it has layers, and they have connects between these numbers, these nodes as they call it. So each of these is a node, and these nodes are connected through edges. And you run the algorithm by saying, I take an input such as a dog, and I run it through different weights, and out here I get some probability that its output is really a dog. So if I give it different kinds of numbers, it will come back with different setup. Now, if you look at this model, it has number of levels. At each level, you can differentiate on different kinds of things. And you train a model to do this kind of work. And you have weights on this. So this is actually translated into a very nice large vector or a large matrix of some sort. And you are manipulating matrices in terms of defining these models. Question? You should ask questions, okay? It's otherwise a very boring lecture. You have a question? Comment? So what happens is these signals, they convert into real numbers. Each edge is like a neuron. It fires, so you train it again and again. And it, over a period of time, it adjusts itself to the point that you get these weights that get fixed to a certain value. And you are then able to predict if a value is true or not, any particular thing you might want to do. Now, how big are these models? These are actually very large models, and I'll share with you a little bit in the next few slides. But one of the breakthroughs that came in was the way these are done. They are actually built up as a next word predictor. So what happens is, like, you have in your mobile phone, for example, you have you start typing, you start to get the next word. So these things are mainly trained, the text models or the language models that generate, they are trained on the basis of finding the next possible word that might make sense, right? And so they generate the next possible pattern, though they are not necessarily very good at reasoning or comprehension. So most of these LLMs which are using this kind of neural network are very good at predicting the next word. So sometimes they are referred to as stochastic parrots. They sound very intelligent, they are very fluent because they're generating the next word very fluently, but not necessarily know how they are doing it. Okay. Now, one interesting aspect of this whole training business is to identify tokens. So what you have to do is, you have to take your input text and convert it, break it into small groups. These are called tokens. So a text like this will get divided into these smaller pieces, like there are complex words like tokenization. This token will be one word, this will be another token. Like this, you break this into smaller parts. So when I'm training the neural network, I use these tokens as a way to train my network. Okay, now this is kind of important to think about because these tokens actually represent how text is written. Now, the reason I want to mention this here in this group is also, now if you wanted to train a neural network on the basis of, let's say you want to observe some stuff from your own area, then identifying tokens very effectively is some research that you could think about, saying, how do I identify tokens? So let's say if you wanted to listen to animal sounds and predict what kind of things they are, right? So it's a language somehow that you want to figure out. Then you need to understand that sound and break it into smaller tokens. And choice of which tokens or the algorithm that you use for dividing that large language into smaller tokens has significance to the kind of training you will be able to do. So when we are talking about training in Sanskrit or anything else, the kind of tokens that get created have a consequence on the quality of the model that gets generated. Yeah.
Why don't you make any alphabet as an token?
Let's say again.
How do you make every alphabet as a token?
See, if you make that, so it's a trade-off, right? So if every character is a token, I'll show you in the next slide. Tokens have the ability to cluster them so that different things that are related to the token will come in the same place. So one of the features of some of these large language models is their multimodality. So if I talk about a dog, that concept dog is a dog, it's a picture dog. You're calling it dog, the audio sound of barking of the dog. All of those are tokens that they can then associate so that they come together with each other. So the ability to predict what is around that token becomes easier. Now, if you use a very long token, right, then you are likely to not be able to differentiate between two concepts that are similar. So like tokenization, token this, that. So trying to find the right kinds of tokens makes it possible to identify concepts that can then be correlated with each other. If you go too small, like every character is a token, then you will not be able to connect facts which are similar into one group in some form or the other. So I'll show that to you in a moment. So here, so like for example here, right? So you have foods, right? So all these foods sort of get grouped into the same area in the neural network. All the toys sort of come together, all the persons come together. This happens because the tokenization allows these things to sort of come close to each other as far as the vector representation of that is concerned. So if you go too degenerate, then you will not be able to sort of relate things together. If you make it too big, then you may not get the right collection to happen. No, they are not all treated as one token, right? So they are looking at, these are all foods together, these are all toys, these are, so there is some work involved in defining the tokens so that you can collect concepts of a certain kind together. Yeah, sure.
See, actually, Prasad, the thing is happening in this way. Mathematics is involved. If you will take each and every alphabet as a token, in English, let's say one alphabet, A. So A, there is a probability, but there is nothing which is like B. Nothing which is like C. Nothing is like D. So the probability will decrease. So it's all a language model now. So if you will say like people, so it's a group. If you will take a language database. So there are words, people, foods, national institutes. So it's like, there are words, but there is nothing which is like B. Single alphabet. So we can't go, I mean, if we go in that way, now, if we take 26 alphabet, all are tokens in the same manner. I mean, for each alphabet, we can't define one single alphabet. We need to go for a word. It's a language, like see, for an example, in group, we are not finding thank you. It is not saying thank you. Why? Because in the pretext, the language is not so refined. We are seeing, I mean, there are very abusive words also. Why? Because that word is coming. It's like this.
So anyway, so the idea here is that it helps, these tokenization helps create a map of all of these in terms of vectors that then allow you to cluster objects that are related to each other into clusters that are close by, so that you can then do some reasoning out of it. So this is really what happens with that. And essentially, each of these things is a real vector, basically a sort of a vector, meaning, yeah, vector of real numbers. And I'm sure you all understand that. And they are all put together so that you can do them. So most of the times, most of this sort of work that happens is mainly related to some kind of vector algebra or a matrix algebra or other things, but at very large scale. So this is really what this is all about. Now let me sort of get you to the next part. So one of the more important articles in the whole history of why machine learning changed and transformed dramatically was this particular paper, which is referred to as a transformer architecture. And you will see reference of this all over the place. And this was done by folks at Google. And it said that attention is all you need. Okay, that is what the article talks about. Now, one of the things that happened when they were looking at transformer architectures was, very simplistically, I'll try to explain this to you, is that let's say I want to predict the next word. If I look at just one word and then predict the next word, there is only, my prediction algorithm will be only so good. But if I could look at the context of the sentence, if I had the ability to look at the previous 20 words and then predict the 21st word, I am likely to be much better off than predicting if I did not have those last 20 words. So the window with which I can sort of work together allows me to do things in a much better way. So this transformer architecture basically said that, just like you are reading the document, you should be able to do this in a way where you can see an entire set of words or a full paragraph or a whole line like that, and then be able to do this. And if you can do that very effectively, then you can get that. So they have an architecture typically which has encoders and decoders, and you combine them to get to the search or to basically identify what you're looking for. Now, there are lots of kinds of models available now. There are open source models and proprietary models. The open source models, of course, you would have seen the most recent one was the open source model released by OpenAI around ChatGPT 2.5. Yeah.
Yeah, so as you mentioned, so all the
Yeah.
so we have text, we have the image, we have the so like how these like variation in decoding like make the token selection and the indexing like does the effect vary effect or like they behave like same? Ultimately like all of them have. And these encoder will transform and use in the architecture. So how much this encoding
No, so these so the tokenization part takes sort of real world tokens and converts them into some kind of a vector in some form. These vectors are run through this whole network and you tune it, and over a period of time, these get pretty good to identify or guess or next word or these kinds of operations. And that's what neural networks do. So if you want to look at some objects which are not text but something else, say video or whatever else, then you need to sort of be able to encode it and represent it in some form so that you can tokenize it.
So I just wanted to know like what's the basic difference between the like a picture encoding and the like which make it more efficient like that. Because if you see the text you type, it come very easy. If you paste like some kind of images, it takes long. Like
Yeah.
So is there a difference? And what is that?
No, so images are a little more complex, right? Meaning text is well studied. They have already spent a lot of time looking at many text documents, and they have most of these foundational models are very well tuned for text and for some images as well. But yes, so it takes some time. Hey, this is a very high level overview that I'm providing you. Go ahead.
For the text for images also we can do this tokenization. वॉइस सैंपल में कैसे करें? चिकन का वॉइस सैंपल.
No, so that's what we have to.
उसका जो वॉइस सैंपल है उसका टोकनाइजेशन कैसे?
No, so there may be some ways to do it. I don't know exactly how to do it for chicken because I don't know how two chickens sound different from each other. I couldn't tell you what the tokenization on that is. But the same idea can be thought of, right? For voice, anyway, people are trying to take so spoken English or whatever else. People are able to convert it into tokens and then put it into the system so that you can guess and relate to that. So I know that something similar may have to be done for chicken or for cows or whatever else. But exactly what should that tokenization algorithm be? That is something for you as researchers to identify, right? Meaning I couldn't tell you the answer to that question. The point I'm trying to suggest here is that there is enough for you to do if you wanted to. See, these existing models will not work in your context all that well because your context is different. If they need to work in your context, then you need to define your tokenization algorithms, your training algorithms, and train your neural network for your data set so that it can answer questions that are relevant to you.
मैक्सिमम जो LLMs तो available है वो for language के लिए
हाँ वो अवेलेबल है चिकन के लिए किसी ने बनाई नहीं आप बना सकते हैं पर
but there is voice sample के लिए available है so voice sample
हाँ मतलब they can understand spoken language but I don't know if they can understand chicken language मतलब I haven't thought of it enough but maybe you can create one but that's an opportunity. So again, open source models, the most recent one is that ChatGPT released an open source version of in the ChatGPT 5 launch that day. So there's some stuff happening there. And there are different variations of it, like, Llama has. I'm sure any of you have tried downloading any of these open source models? You have? Okay. Which one did you download? Claude? Claude is not that open source actually. Huh? Yeah, but I think, try DeepSeek or Llama 3. Those are really quite popular right now. And you can build your own model on top of that. Okay, now let me just skip through this. So now one of the questions that get asked a lot about is hallucination, right? But if you look at the model and you're answering against the model and not doing a lookup, clearly you are making up new things as you go along, right? So that is clearly, it is asked to be creative. So it's generating new stuff even without it being there. So when you are looking at languages and documentation that is there, you are not always answering from what is already present. You are trying to build a model and then predict the next set of words. So you will get all kinds of new and interesting observations from this, which is why some of these models hallucinate, right? And that is really a feature of the model rather than a bug in some sense. Now, if you don't want it to hallucinate, there are different ways that you can run your system so that it doesn't hallucinate. Now, if you look at, for example, what Perplexity does. What Perplexity does is it uses a model to generate some new facts and then validates those facts against a lookup that it does against, say, a Google or whatever else. So that's how it ensures that the result that it is giving you is a result that is actual fact rather than just a made up idea. But if you want to write a creative poem, which has never been written before, then AI can do it because it's using the model to create these new hallucinations. Okay, I'm going to tell you a little bit about training. So now when you try to train data, right? So these are the steps involved in training the data. So you have to first have data and you collect a lot of data. Then you clean that up, create tokens. Then you use some pre-training, fine training, and then once you have trained it, then you use humans to ensure that what is trained is making sense. So it's a fairly tedious task of doing this. Now, if you wanted to do this kind of training on your kind of data, then you must have enough data and enough systems to play around with it. And this is not that easy because a lot of times you don't have this high quality, large volumes of data. Now, when you look at the LLMs, right, for example, the ones that you can get in the market like OpenAI and all, which have crawled the entire internet, if you look at what exactly have they crawled, so there is a system on AWS called Open Data Sponsorship Program called ODP, and they have something called the common crawl. So they don't always go around looking for each one of them. They buy this common crawl. You can pay money and get common crawl. Now, common crawl has already crawled public data sets such as books, Wikipedia, news articles, all the web scrap, various language examples, code repositories, specialized data sets, curated data sets, and a whole bunch of things have been already crawled and are available. So anybody who wants to train using a common crawl, you just subscribe to this Open Data Sponsorship Platform, ODP, and get your entire crawl, and then you can get it. Now, clearly, one of the interesting things or important things to note is that in the process of crawling the entire internet, it has crawled good, bad, ugly, everything. So it has all the biases that the internet already has, which is where it is. Now, if I were to say, oh, I want my crawl to not have this and that, it's much harder for you to do that because the crawl that you are normally subscribing to is already including everything in there. Okay, I'll skip through this. I think I'm getting too detailed here. I'll share the slide deck with you. Let me just get to the more. I see I'm losing people here. Let me just switch to the other slide deck. That may be more fun. We'll come back to this if necessary. Okay, let me focus on this right now, and then I'll come back to the other one if necessary. So the whole question is, if AI does everything, then what will we do, right? So as I said, I posted this on LinkedIn. I got 780 comments. You can go online and look it up. You should see some very interesting comments that have come up on this particular article that I posted. This was about 4 weeks back. I got, 250,000 impressions. So I asked ChatGPT. No, so I have them in this somewhere. But if you go online, I've shared this deck. So this deck is available online and you can download it. And it has all the many of the comments. And if you go to that, you will see the comments also. So I asked AI, if I'm asking this question to other people, I should ask ChatGPT also. So I asked ChatGPT. So if AI does everything, what must humans do? So this is what ChatGPT told me. Focus on meaning, not just tasks. Develop judgment, ethics, wisdom, build relationships, solve problems AI can't, suffering, purpose, justice, all these kinds of things. I asked the same thing to Claude. And Claude said, you should know how to ask the right questions, build authentic relationships, judgment, innovation. Future belongs to humans who amplify. Okay. Then I asked ChatGPT, okay, if I were Jeffrey Hinton, what would he say to this particular question? So he gave all this stuff. And Hinton thinks that we should act as moral, philosophical stewards of technology. Just one question. How many of you have read this book called Nexus? Any of you have read this book? Yeah, it's by Harari, Yuval Harari. Have you read any of his books? I'm sure you have read many of his books. So this one he wrote about a year back. It is quite, he has a very negative view of AI. He thinks that AI is going to eat us all. And his comment is like this. He thinks that, okay, let me try to summarize a fact book in few lines. What he mentions is he's a historian, right? So he writes about historical things. And he shares in this that humans have used fake data, unnecessary things to be very mean to other people. I mean, we have killed people on the basis of unverified facts historically. And he gives many examples of this, Romans, the barbarians and all that. And even more recently, if you look at, we were in Auschwitz about 2 years back, and you can see what Hitler did there. You go to Vietnam and you can see what was going on, South Africa, Gaza, all these places. It's very sad what humans have done on the basis of very limited information. So his claim is that AI has the ability to generate so much fake information that you would have no idea what is truth and what is not, right? So that's why he thinks that AI is really horrible. And that's what, you should read that book. It's worth reading. It's pretty fat though. I must admit that I didn't read the book. I heard it on Audible actually. So I was traveling and I just downloaded it on Audible and just heard the whole thing end to end. quite nice. So this is, as you would realize, you would want AI to, so what the biggest problem is? Pushing everything AI wrong direction. I want AI to do my laundry and dishes so that I can do art and writing, not for AI to do the art and writing and for me to do the laundry and dishes, right? Okay, let me explain to you a little bit here. So this particular chart, if you look at the x-axis, it is about expertise, and this is about productivity. So in the beginning, when you start using chat and all that, it starts to feel like it is helping you a lot. Okay, you see improvement in your performance. But if you start using it a little bit more, you find that it's too confusing. You get way too many options, and your productivity actually goes down. And then you can get into this co-pilot zone where you will get preset advice, okay, within a limited area. And then you can get 20, 30, 40%, 50% improvement in performance. But then if you get to this side of it, where instead of using AI for factory workers, you build AI factories, then you see exponential improvement in performance. And you can see that with various agents and various other technologies. Okay, so agentic AI systems are quite complex to build, and they are going to require complex engineering to build it out. Have you tried any of these agentic AI systems? Any of you? No. Now, as I said, we are at the beginning of the AI journey, and if you want proof of this, you should see what's happening in the news right now with Zuckerberg hiring people at $100 million plus to a lot of these employees that he has hired. I'm sure you have seen the news. So clearly he thinks there's something more happening in AI. Otherwise, why would he hire so many people at 100 million plus, right? So we are still at the beginning. There's a lot more AI that needs to be done. And I think the next 5 to 10 years are going to be very exciting for AI. And for many of you here as students, you may want to think about how can AI affect your jobs, or how can you, using AI, affect new things, find new research, new realizations, or whatever else, right? So this I will skip. But yeah, he has been hiring people like crazy. Now, this particular thing, if you look at these interesting problems that people talk a lot about, personalized advice, production, and you can come up with all kinds of ideas of what kind of things you would like AI to do. Detect outbreaks early, automate diagnostics, deliver adaptive, personalized vernacular education to rural and remote students, and all these kinds of fantastic ideas. They will not happen just like that. Somebody will have to make it happen. So this is where the opportunity is. So you can take a problem like this and you can get AI to build products that can do all of this stuff very efficiently. And so you'll need people to do all this work, just software engineers or other people like that. So this is the opportunity part of it. Now, in terms of writing code, people are saying that AI is definitely writing better code than humans. So this one is from Dario, the Anthropic CEO. He's the guy from Claude. He says that in 6 months, he believes that 90% of the code will be written by AI. If you look at Microsoft and Satya, he talked about 30% of AI, of Microsoft code today is being written by AI. And then NVIDIA also, he said something pretty crazy like that. But I want to share one sort of example here, and this may be something to think about. So chess and AI is a very nice analogy that you might want to pull around. So what happened is that if you look at chess, and how many of you play chess? Many of you play chess. At least some of you know and have followed chess. Chess has been always a very nice problem for computers to solve. From very early on, people have thought of how do we write chess playing computers. So in 79, Ken Thompson designed a chess machine he called Belle. And then in 1989, Kasparov, who was the world champion, defeated IBM's Deep Thought. But in 1997, Deep Blue, which was IBM's machine, defeated Kasparov. Since then, chess engines pretty much defeat humans 100% of the time. And it is very hard for humans to compete against good quality chess engines right now. In fact, Stockfish, which is one of the well-known chess engines, the ELO rating is 3800. And if you compare this with Magnus, it's 2882. So even Magnus cannot defeat the chess engines all the time. So now, if you think through this, in the mid 2005, 6, 7, I was sort of involved in this because we gave away chess players some computers to train themselves. And there was a lot of discussion that the quality of what is left to play, you humans are going to get defeated by computers. Why would anybody play chess? The game is dead and all of that. But if you think about the game now today, it is back into full swing. We are like, chess is everywhere, and Indians are sort of all over chess right now. And if you talk to the grandmasters, you will find that the kind of chess that they play now, the moves that they would make now, are very different from the moves that people in the chess world made before computers were starting to become important. So people have accepted the fact that you're not competing against chess, meaning computers, but you're competing against each other, and everyone is using computers to learn how to do this better. So we have to figure out a world where instead of trying to compete with the computer, we have to sort of adopt and accept it and live with this world where, how can we get better because of this particular thing. I don't have it written down here, but are you familiar with Lex Friedman? Any of you hear him? So Lex Friedman has a very nice podcast that you can listen to him online. And he did a podcast with Demis Hassabis from DeepMind about 2 weeks back. And he talks a lot about how he designed AlphaFold and all of these other things. Quite interesting in case you are interested in that. So AI will write better code than humans. So what should software engineers do? So again, this I was talking to many of the IT people as well. But the main thing is that you need to define the problem. Asking the right questions has become much harder than just doing this. So I do expect that some of you who are doing scientists, let's say you're working on human science or say animal science here in this case, you should be able to find related stories in humans or other places by asking the LLM to answer those kinds of questions. So your ability to connect facts across unrelated subjects is lot better now if you could ask the right questions. So AI can really help you apply discoveries that have happened in one area into another area. So I do expect that you will see some good, interesting discoveries happening by bridging disciplines or combining domains or asking questions about some other area in the context of your data or your own problems. And yeah, meaning ascertaining what is truth is going to be pretty tricky. And we just talked about that in the context of the Harari thing. And building responsible AI solutions is going to be very tricky and as we go ahead. Any questions? Now, this is, I guess you may not appreciate this chart all that much, but I have used this chart for about 20 years now. So in 2008-9, I was selling cloud computing in a big way. So take your entire system and move it into the cloud. So the discussion would be that, I have such complex systems right now. I'm going to convert it into one cloud and everything goes to the cloud. 20 years out, only 30 to 50% of all the systems have completely moved to the cloud. There's still enough happening within the enterprise that it just takes a long time to move to the cloud. The same thing we did about 10 years back, where we started to use APIs for doing this. So everyone was using APIs and those sort of got moved again. And I see the same thing happening in AI right now. Sorry, in agents this way. Sorry. Let me go a little faster here. So actually, there are lots of opportunities. What is being referred to as AI plus X, and in this context, this may be making more sense. That AI on its own has its own path, and a lot of action is going to happen. But I think there are opportunities to apply AI to biology or biosciences or healthcare and medicines or agriculture or any of these areas. So I think the opportunity of combining your skills with someone who has AI skills together and bringing those together uh, can create next generation of opportunities that are quite unbelievable. And that is something you may want to think about. And I'll give you one more example on this. So if you look at Microsoft as a large company, they have GitHub, which has the source repository for all the code of the world in a way. Right? And they have all the programmers that you can imagine. Now, despite having all the programmers and all the data that they might need, they have taken several years to write enough code to build autocoders in some sense, right? So if Microsoft took almost 3 years to build their own coding engines, despite having all the data and all the knowledge, trying to do that in another domain is going to take a lot of time and energy. So the kinds of LLMs that we do with today with respect to language and English or certain kinds of things, if you have to apply them in your area, so if you wanted a prompt based system to design a bridge or something like that, it's not trivial to do that because the data for bridges is not available and nobody has kind of uploaded that in the same format. We are not necessarily able to represent it all that well. So like this, if you take your field, right, and try to think about what might happen, what is possible because of generative AI systems, I think that's a good opportunity to think about some exciting new ways of doing research that may be quite unique for what you might look ahead. The key to getting good quality AI is to have good quality data. And this is one challenge that I've seen in general in India, especially, that we don't have good quality data for anything. So if you have good quality data of certain kinds, then you already have a leg up in some sense in trying to do some amazing AI because it needs good quality data. And if you have good quality animal data, I think that's a good starting point for doing animal related AI. I'll skip through this. Let me show you something else.
Is there any requirement for what is the minimal set of data requirement for any?
The more the better. The better, the more data you have, the better granularity of data you have, the high quality data you have, the more the models will be more meaningful in it. Without adequate data, you cannot really generate AI like algorithms on them. I think maybe you have a comment on that.
I also face the same problem of the data. What I use publicly available data, made the model on it, train the model, and then apply it to our.
Yeah, so I think this is one of our challenges as well. We don't have good quality data to really work on it. But problem is if the data is through a model, then you may not get good quality results as well because
Yes, but it's a challenge, sir.
Yeah.
But we need to go somewhere now. That's why I did it. Cattle or sheep, we just for the data, the breed photograph, and then we augmented that data, different poses, and then try to make that tool to predict that this is this breed, this is this breed, cattle and sheep, and we are trying to figure out the same things for the voice samples of chicken, cattle, these things. We need data.
Yes, that is a big issue. And this is again another comment here that if AI is starting to get deeper into vertical, the ability to connect different facts is going to be the key for some of you here. Let me just get to one particular set that I want to share with you. Okay. So this was, a few months back, I had a chance to present to the BRIC people on what we should do with respect to BRIC and AI. Okay, so I'm going to give you some ideas here. So if you look at AI to be done, you need these 8 different things. So one is you need AI models, you need high quality data, you need some compelling problems to work on, you need biology experts who understand the domain. But in addition to that, you also need AI experts, you need software engineering, AI platforms, and funding. So the government in India has created through METI a whole set of AI platforms. So they have made some large GPU investments, and you can kind of get access to GPUs from METI, from one of their AI missions that are part of it. What I think we should do here as part of NIB is to find local partners who are AI experts. So potentially out here, I was suggesting you have IIT Hyderabad and potentially Triple IT Hyderabad as well, which are very close by. Triple IT Hyderabad is less than 10 kilometers from here, 5 kilometers, Gachibowli. So if you can get some of them to work with you, then you can get the AI work coming in from some of the students out there, and you have the domain and expertise, then you can work together. I think we can solve some interesting problems. And you have the ability to solve local problems because we have local data, local problems. Nobody is going to solve them for us from outside. And I think DBT has some funding for these kinds of things. I don't know the exact details, but there is a desire to fund such projects. So some of the suggestions that I had given was to help create capacity. So everyone needs to get trained on AI. So I don't know how you are going to learn about AI, but we should do some more systematic AI training for all of you. I don't know how it's happening, but that may be something to think about. I believe that a lot of the research in biology will also happen through agentic AI. So a lot of the steps that you have for research, evaluate this, evaluate that, find literature surveys and all that, AI can do literature surveys very efficiently. So I think it's worthwhile building out some platform for literature search so that any grad student who wants to do it can easily start using that platform and will get much better quality results and pre-summaries and identification of the right papers and all of that kind of work. So I think we should put some agents on our libraries in some form to get some of this work to happen. I know we have a biological database, and I think we are setting up an animal biology database here, which is quite exciting. One other important thing is going to be model validation. So as soon as you build out, AI will generate a whole bunch of new things. So if you look at protein folding, for example, it might tell you target medicines and various other things, but those have to be validated. So we need to set up a pipeline where you ask AI to generate, and then real humans or systems or robotics to actually validate if that is true or not. And that is some work that I think may be worth thinking about. Digital twins is again going to be a very interesting opportunity. So the animal models that you have built in the past, right, are very similar to AI models. Can those be built again fresh using AI in a big way? So I think there's a opportunity here in something. The knowledge graph systems are also another interesting thing here. If we can correlate facts that are already present, somehow connect them, and connect what you do with animals with, say, other species, plants maybe, or even humans, then maybe there is some connections that can be found because of AI. This is very hard for humans to look at these kinds of connections, but AI can do this very efficiently for you. And then, of course, Ayurveda is another area that people have been looking at. Images, again, I'm sure you are familiar with the capabilities that images can do. So if you have images of biological samples or animals in your network, then can those be used for building better quality models? And I think that's what you've been working on. And then agriculture, again, has got lots of different opportunities. Many open areas in India for us to look at AI and agriculture. I know lots of startups who are trying to do this, but if you're thinking about good problems to work on, then this would be another one.
Sorry.
Yeah.
Here I want to make a point. If we can, let's say for an example, the image data. If you can take the complete image data, let's say it is produced by an AI, poolside counting, overview images, whatsoever type of image, different types of and if we can only take these images and if we can apply our AI tools. Now see, we are having some AI tools which are trained on the breed identification of, let's say, cattle and sheep. Can we apply those tools, those techniques on this data?
Possibly. I don't know the answer to that question. That's what I'm saying. So we need to do more research in these areas. And what I'm recommending here is that,
let's say for an example, two-side counting. Let's say for an example. So we can, these tools can be more efficient to solve this type of problem. Because image analysis anyway we are doing in our laboratory, but we are doing for a different objective. But if we can, just to start, we can at least do for this. We can take the complete data, or the image data, and then we can analyze. We can search this with the pattern by means of our tools. And if you can comment on.
No, I think it should be possible. I just don't know how to do it. Meaning, I don't understand enough about what those images are. But what I think is that, yes, I think these kinds of experiments need to be done. And again, this is going to require some people who understand AI models, building models and all of that, and some people who understand the domain.
See, so we are having two different, one set of people who are trying to have some expertise on AI, but they are not having the data.
Correct. Correct.
Or they are searching data on the internet.
Correct.
Publicly available data.
Correct.
Can we club them?
No, exactly. So that's why, we should club them. Absolutely, we should club them.
We can club these two people together.
Correct.
Then I think it can make sense.
No, I agree with you. So that's why what I'm recommending, that since you are all in Hyderabad, we should go visit either IIIT Hyderabad or IIT Hyderabad and convince their students to work with us. So I did this experiment with Kalyani group. Which one is that? NIBMG and IIT Kharagpur. So again, the problem that we found is that NIBMG has, again, very similar, lots of scientists and PhD students. They don't have undergraduate students. And IIT Kharagpur has only undergraduate students, a large number of them. They have 500 students in computer science, AI, software per year in their undergrad class. So I tried convincing them to work together, saying, why don't you get your undergraduate students to go and play around with this sort of biology data from the group, because both of you are in West Bengal, at least you can meet. So they have had some meetings, and I think in this whole AI proposal that came around, they had some good proposals actually. But it needs both kinds of people to work together. Some people who understand the domain and some people who understand computing as well. So I would highly encourage looking at collaborating with CS departments in the universities around here. Let me stop here. I think we can keep going, but I might as well answer questions rather than just show you more slides. I'll make my slides available. Yeah.
So in healthcare biological system, we don't have the structured data. That is the minimum requirement to build any AI. For any like machine or anything like cars, we build AI-enabled camera. The car is defined, but in case of healthcare, we have so much of variation. So if we get the data, and what should be the minimum data we get to start or to build a model which is reliable, and maximum limit, I think there is no maximum limit. We can define the model based on the data availability. So in your opinion, what should be the minimum criteria to get the data that we should have at least this much data?
See, more data, the more data you have, the better you are. There's no question about it. Thing is, we need to start tagging data consistently. Otherwise, you have a problem. So right now, one of the problems that we have in India about healthcare data is we don't have consistent tagging on it. So if you go to one clinic, the convention that they use is very different from the convention another clinic uses and all that. So some standardization will help. If there is some standard way of keeping that data, then you will be able to ask the right questions. So I think there is a lot of work that we need to do on quality of data that needs to be collected. But I think we are making progress. So today with AI, you can read unstructured text and still make structure out of it. It takes some work and might lose some quality, but you can still do it. So I think there is a research opportunity in trying to figure out how to create structure out of unstructured data sets.
So thank you, sir, for that fantastic lecture. A round of applause again for the sir. So if anybody has any other question, they can ask now.
Yeah, go ahead.
My question is, you are from assistance, you know AI and all this expertise. So when the author said that coming future, the AI will take up a lot and all, and so regulation is required for that. So if you are from the industry who is building AI and all, so any one or two point which is in your mind where we need that on that point for regulations, which is required in coming future to regulate the effect of the AI. Because you are doing it or developing it. So if you are sitting in the policy chair and if you are drafting any one or two point, or put those points, at least one point, which we should be careful. I hope I have.
Yeah, no, I understand what you're asking. So see, I think one of the important things that is going to come up is who's going to be liable for errors or mistakes that happen, right? So AI, so this is a big debate going on all across the world is who, if an AI makes a mistake or does something wrong, who is responsible for that mistake? Right? Is it the guy who wrote the program who did it? Is the data that was provided wrong? That's why he's doing the wrong thing. So this whole thing about who is responsible and who takes liability of these kinds of problems, that is really one of the major discussions that is going on. Right now, nobody is responsible for these at the moment. So if AI does something crazy, nobody is really taking accountability for it at this moment. So somebody will be held accountable for that. Once that happens, I do expect that people will be far more careful about releasing agents without knowing what they are doing with it. Yeah.
Recently, there was this interview where Sam Altman spoke about the need for privacy laws in AI.
Yeah.
So, like once, as you said, Métis had this GPU setups and all. So once some people start training data on that, and that same model is used by researchers in some related fields and all for discoveries and such. So, at what point would IP be safeguarded, and what point would it be like the data, personal data was used, or some other protected data was used, and it should not be like for fair use and all?
Again, this is again an open question right now, but let me split it into two parts. Okay, one is of course personal information. So when you share your personal information, it should be shared with a purpose. I am sharing it with you for this particular purpose, and you should not be allowed to go beyond that. So if you shared your personal data for, let's say, for verification or something, or it was given to some particular cause, without your permission, they should not be allowed to use it anywhere else. So that's the basic requirement for personal information. So your personal data sets. If you gave it to your doctor, you gave it to him so that he can treat you for that medicine or ailment that you have. You did not give it to him to circulate it to the rest of the world. Right? So that is an important distinction that needs to happen. And there is some laws that are coming in, or some that have already been defined on that specific point. So that part is one part. The second part is even trickier. So where you can say, okay, AI learned how to write poems using Shakespeare and everyone else. Now, it used that knowledge to train itself to now write next generation of poems. Is that violation is that stealing. So is it, so let's take, for example, you were asked to write an essay or some topic. AI learned all of it and created a new essay. It's original, it's new, but it is based on learning that it had on all the old stuff, right? So now you say, no, you should not be allowed to learn on data that is not yours, right? So there is one argument on it. On the other hand, we all are based on the previous generation anyway. So everything that we have learned today is on the basis of something that was done. So if we are allowed to learn from other people, should AI be allowed to learn or not? This is a huge debate going on right now. And it, to some extent, I think the way it will get addressed is creators will start to get some payment for the results or the benefits that AI generates from some of the work that might happen. So I think that's sort of where it will end up. Same is happening for music, for example, right? So AI will listen to music, it's already doing that, and it generates new music. So it's not stealing from one existing old music, it's just generating new music out of learned from everybody else's old music. Who should be paid for all that stuff, right? So this whole copyright protection, privacy, all these issues are very open and nice, open, difficult issues to answer right now. But I think it's a trade-off, right? If you regulate very early, like Europe is trying to do, then you don't get new discoveries. On the other hand, if you look at Trump's new AI Act that he released about 3 weeks back, they have basically said there should be no regulation for some time. So we'll see. Yeah.
You see all these LLMs, they're mostly discovered in, invented in USA or China.
Right.
So where is India in terms of its own LLM?
Yeah, I think it's a very good question. We haven't done enough right now, clearly. But if you look at, so actually we are in deep shit in this matter. I think this is true for all of research. Our research is not quite at the level at which it needs to be for us to claim that we are third largest, fourth largest economy in the world, right? So I think there's a lot that we need to do to improve our setup, and that's true here as well. But one thing I may say is that if you look at sort of the evolution of things happens, first you have science, then you get technology, and then you get engineering. India has done better on the engineering, hasn't done as well on science and technology. We have very few original discoveries and things like that at the scale at which they need to do. Of course, you guys have done great work here, but for a country of our size, we need to be far more active and aggressive in research. And we are definitely not there. Yes, ma'am?
In some cases, there are still like examples where we have to show, suppose I'm writing a thesis, so I have to show not just in case of using plagiarism, but also I have to show a report of having any AI content. So isn't it very contradictory that on one side we want to develop the AI and this technology so that we can use it more often, but on the other side I have the cons of having the AI content, because in the equation that you showed, productivity and work, if I am supposedly using 50% AI help in my thesis writing, so I must be using that time in doing something else. So isn't it very contradictory that we have to not show the AI
will get
content?
resolved later on. I think again, I think when we are still early in the game, right? So people are not very happy to. This problem will get sorted out in a few years' time. The reality is that when you have classes and colleges, then you say, okay, if I ask you to write an essay, everyone has been given an assignment. Are you allowed to use AI? You're not allowed to use AI. Who knows, right? Eventually, these things get sorted out. So I'll give you a story from my college days. So when I joined Kharagpur in '79, we were not allowed to use the calculator. Okay, we used to have log tables. How many of you use log tables? So there was a lot of discussion that log tables, if you use the calculator, your brain will not be able to use log tables anymore. But after my first semester, they sort of said, no, it's not possible. Everyone must go buy a calculator. So we were all given us some scholarship, but otherwise given some money. Everyone went and bought calculators. And then on, everyone used calculators. There's no way you can be in an exam where half the class uses calculators and the other half uses log tables. There's no competition. So everyone had to use calculator. So yes, over the years, my ability to use log tables has gone to zero. I could barely use them now. But so what, right? So this is again a nice debate. Like this, AI will also come in. Now the question is, if I gave an assignment, and I heard this from a few people who are teaching computer science courses. So what he said is that he first asked the assignment, gave the assignment, saying, I'm going to give you each an assignment, but nobody can use AI, and strictly enforced. And in the second half of the semester, they flipped it, and he said, you cannot write your own code. You must write prompts to generate the code that you must do. And clearly, if I gave you the same assignment, the results that you might get out of each one of you will be very different. So even though it's the same assignment, you all have access to AI, but the prompts you might write would be different. So you may not be able to use that. And in some sense, if you go further, right? So if you look at AI, first it was word. So you have spell checkers. So now everybody expects everyone is going to use spell checkers. So yeah, maybe we can't spell as well. Then you have, I know how many of you use Grammarly. I use Grammarly all the time. So it gives me like, everything is there. Then you use Copilot and it changes words within a paragraph. And then you say, man, this is too slow. Just take the whole thing and give it to Claude. And then you get a very nice document, right? So this is starting to happen. And I don't know when it'll hit the dissertation part, but one of these days.
So, Dr. Ananda, I have a question which is really bothering me for quite a long time. So, are we pushing the humankind towards a regressive evolution by using and developing AI to do better job than human? So now we almost stopped using our own brain power for calculation, remembering, creating, doing anything, creative thing that people used to take pride of. So what is going to happen to the human evolution?
Yeah,
The
that's a
life's
good
evolution.
question, right? I asked this question as well. So if you look at cultural golden ages, right? So when there is prosperity and people are not worried about their own jobs and life is good, people pursue art.
Yeah, but now art is done by AI.
You could do some other form of art. You will see sports, music, science.
Every
New
form of
genres.
human creativity is taken over by AI.
No, not taken over. It's assisted by AI. So today I really expect, like for example, I was telling this to someone. I think the application of physics into biology or biology into physics. Now these kinds of interconnections today are possible because you can ask AI to say, hey, think like a physicist and answer this question. Right? Use the rules of physics to answer that question. Then you might get very new kinds of answers. So I think having a few hundred slaves working for you continuously might give you more power if you are willing to exercise it.
So it is almost like we wanted to come out of the, as you taking your example, that we should not keep anyone as a slave, but we used machine to do our work. But not, again, slowly we are kind of getting fond of machine slaves and getting into there.
Yeah.
I don't know. Means human evolution is going to be regressive. We will be slowly getting dumb to dumber. Because our ability to
No, so what
remember
happens in
things.
these situations is some people get dumb to dumber, but some others get smarter.
This means there is a difference. Will be
Yeah, so I
created,
think,
not bigger.
yes, absolutely. And this has happened everywhere, that the haves and have-nots, the spread starts to increase. some people realize that, okay, now that I have this superpower, I can build a company with 5 people and I will just don't need so many people to hire. I have this brilliant idea. I don't need programmers. I'll write code and it will generate all kinds of things, right? So people become more powerful because they are able to exploit it. On the other hand, some people will say, well, I don't need to do anything. Somebody else is going to do it for me. So I will become lazy and not do anything.
So it will create actually more inequality in the society. Which
Yeah,
the society
it's already
we want.
happening, right?
Already is there. But as a country or even as a globe, ultimately the political people, or let's say at the policy level, we do not want.
They like
we
it,
want
right?
to-
No.
The ultimate aim is
Politicians
to
like
reduce
the
inequality.
That's utopian. Politicians like inequality. They can exploit it better.
Okay. Thank you.
No, but the fact is that yes, the haves and have-nots will keep increasing. I see that all the time. I also believe that we are heading into a world where universal basic income will happen. Everyone will be, nobody will be very poor. Because, government will provide some money to everyone. Which one?
AI model for this generation. Of course, learning is fantastic. What we are learning very quickly. But finally, what we build up at the end of the day, anything is innovative.
It depends on what you build, right? No, it depends on what you build. You can make innovative things happen. Okay, I think we are.
Yeah.
Thanks a lot for inviting
Thank you very
me.
much, sir. Thank you.
Sorry, it was all over the place, but I'll share there are 2 decks here. I'll make sure that they are available to you. I'll make a PDF in the evening and send it to you.
Thank you, sir. Thank you very much. Now I request Director Ma'am to kindly felicitate our guest of today.
Let me log out. Yeah. You want me to come down or?
I think he's going
After
to
vote.
say a word of thanks after that.
So thank you, sir, and thank you, ma'am, for that. On behalf of NIAB, it's my privilege to deliver the vote of thanks. First and foremost, I extend our heartfelt gratitude to Dr. Anand Deshpande for delivering an inspiring and thought-provoking lecture on the digital cow AI for better breeding, health, and milk. I'm certain that this will inspire our researchers and students to think better and bolder. I sincerely thank our director, madam, for her vision and encouragement in making this event possible. I would also like to thank members of the event organizing committee, scientists, administrative staff, IT team for their support, and students for their presence and engagement to make this event truly meaningful. Thank you for your time and attention. May I now invite everyone for a group picture followed by high tea.